Hey guys, welcome back to the channel. In this video, I'll be covering algebra functions. Before we hop into the meat in the video, please subscribe to the channel, leave a like down below, and comment any topics you guys want me to cover and any feedback to help me improve the channel. Also, I do have an Instagram page for the channel, link in the description down below. Let's just hop right into it. So we've covered the graph of functions. So let me move this paper out. So we covered the graph of functions. We've covered the transformation of graphing functions, the transformations, and the domain and range of functions. So we have two things to. So left we have algebra functions, and we have MB. We have a little bit of just more transformations. Then we have individual functions before we could really get into pre-calculus and calculus. So for algebra functions, we're looking at two things. We are looking at the operations so we look at the operations that go into a function and how those operations affect the domain and range. All right. So say we're given functions f and g. All right. The question we're asking is what happens when we apply any of the five operations. So with the domain, we with the domain, any and all values that that both f and g have in common. Let me zoom out a little bit for you guys. Oops, a little too far. Both f and g have in common is the domain of the new function, and also any piece of functions that are not included in f or g are excluded from the domain of the new function. So if you guys remember, we have so for functions we have five operations. We have adding, subtracting, multiplying, dividing, composition. All right, this is it's its own topic, and these four are what we're going to be covering today. Okay, so what happens? So say we're given let x squared minus 3 equal f of x, and g of x is equal to 4x plus 5. So we're trying to find all the resultant functions if we were to add and subtract them. So adding. So if we were to add to add the functions, it's f of x plus g of x is equal to f plus g of x. Okay. So we have x squared minus 3, which is our f of x, plus 4x plus 5 is equal to f of g, f times g of x, or f plus g. Sorry, guys. So essentially, we combine like terms, and we get x squared plus 4x minus 2, or plus 2, is equal to f plus g of x. Now you guys might be asking, what is the domain? All right, so we'll cover this in polynomials, but so pretty much we could plug in any number. So we could plug in any value for x, and we would get we'll get an output. We won't get it won't be undefined. So the domain is negative infinity to positive infinity, meaning all real numbers. You will also see it as written as all real numbers. And you guys will also see it in a superscript R. All real numbers. All right. So note all polynomials. This is a polynomial function, which we'll cover once we get to that polynomial function. Have domain. Okay. We're not really focused on the range in this case. We're just looking at the domains. We'll cover the ranges once we cover the different ways of graphing these functions. But so let's keep going. What if we subtract? So move this up real quick. Sorry guys. So we have f minus g of x. So we have is equal to f of x minus g of x. Well, pretty much it's equal to the our f of x. So our f of x is equal to x squared minus 3 minus 4x plus 5. All right, applying the distributive property, we distribute the minus. Be careful to distribute the minus every time before you guys add and combine like terms. That's where a lot of people go wrong. X squared minus 3 is equal to minus 4x minus 5. We combine like terms. X squared minus 4x minus 8 is equal to f minus g of x. And then this is also a polynomial. Negative infinity to positive infinity, all real numbers, is the domain. Multiplying. So f times g of x is equal to f of x times g of x. Okay? Pretty much we take our x squared minus 3 times 4x plus 5. Okay, so this applies to the distributive property. We're going to FOIL. So the first term, so 4x cubed, and then we're also going to get, so this x squared goes to the 5, plus 5x squared, this 3 to the inner term, so minus 12x, minus 15, sorry guys. Combine any like terms we have. It looks like we don't have any, so this is our f times g of x. And since this is also a polynomial with degree 3, our domain is negative infinity to positive infinity. All right, so we have one last one before we end this video off. Division of functions. So we have f over g of x. It's equal to f of x divided by g of x. So what this is pretty much remember, g of x cannot equal 0 because we cannot divide by 0. It gives us an undefined expression, makes the expression undefined. So pretty much, here we go. So let me zoom out a little bit here. So pretty much we just plug in our f of x and g of x. So f over g of x is equal to x squared minus 3 over 4x 4x minus 5. So pretty much there's only one value. So in this case, there's only one value of x that x cannot be, which is this piece right here. And this is what we call a rational function. All right, so we write a statement 4x minus 5 cannot equal 0. So 4x is cannot equal 5. X cannot equal 5 over 4. So if we were to write this, so we could leave it like this for domain. Or we could write it as negative infinity to 5 over 4. A union 5 over 4 to infinity, which we'll cover pretty much in a future video, talking about interval notation if you guys would like. So just a quick recap. We have We have 5 functions, or 5 operations. We have multiplication, division, adding, subtracting. Yeah, so we can add, subtract, multiply, divide, and we can also compose functions, but that's going to be for a later topic. The domain is we just add the functions pretty much in combine like terms. Multiply any terms necessary. Then if it's polynomial, the domain is all real numbers, because there isn't any function there isn't any number that makes the function that makes the equation or makes the expression undefined. But if we get a rational function, it can't equal 0, and we'll cover more as we go into each individual type of function. I'll see you guys next video.